Before we get to the story, I'd like to say thanks so much for visiting my new channel. I'm going to be uploading cosmic horror related stories every single day. So if that sounds good, please drop a like and don't forget to subscribe. It means a lot, especially when just getting started. I hope you enjoy the story. I read water for a living. That's the simplest way to put it. I'm a deep ocean water chemistry analyst at a university oceanographic institute on the coast of Hawaii, and my job is to process seawater samples collected during research cruises across the Western Pacific and tell people what the chemistry means. Research vessels go out. They lower a CTD rosette to depth. Water bottles snap shut at specific intervals in the water column. The samples come back to the lab packed in coolers, and I run them through the analysis battery. Dissolved gases, trace metals, dissolved organic carbon, nutrients, isotope ratios. Every water mass in the deep Pacific has a chemical signature, a specific combination of properties that reflects where the water came from and what it's been through and how long it's been down there. 17 years of reading these signatures has made me fluent in them, the way you get fluent in anything you work with closely for a long time. My name is Tess Kubo. I'm 43 years old, and I don't go on the ships. That's an important distinction in my field, where the field researchers who collect samples at sea and the analysts who process them back on shore occupy different professional worlds that occasionally overlap. I've been on one research cruise in 17 years, early in my career, and I decided the lab suited me better. I like the quiet of it. I like the way the data comes to me and I work through it, and the chemistry tells me what it knows without any of the seagoing drama attached. I've been the primary analyst on Mariana Trench sample sets for 11 years. The Challenger Deep, the deepest point in the trench and the deepest known point in any ocean, has been sampled sporadically over the decades, not as frequently as shallower Pacific stations because getting water bottles to 11 kilometers and back is technically demanding and expensive. But there's enough historical data to establish a baseline, a chemical portrait of what the deepest water on Earth is supposed to look like. I know that baseline well. I've worked with it for 11 years. 2 years ago, the baseline changed. The sample set that started all of this came in from a research cruise that had made a series of CTD casts in the Challenger Deep as part of a broader Western Pacific survey. 12 samples from various depths in the water column above the trench floor, including 2 from the extreme deep, below 10,000 meters. Standard collection, standard shipping, standard condition on arrival. I logged them in and started my analysis the way I start every analysis, methodically and without particular expectation. The deep samples were off. The dissolved organic carbon in the 2 extreme depth samples was elevated above the established baseline. Not dramatically, but clearly outside the range of natural variability I'd expect from the historical dataset. The trace metal ratios had shifted in a pattern I recognized immediately from other contexts. I've analyzed samples from hydrothermal vent sites and from areas of high biological productivity, and the trace metal signature of biological processing, the chemical footprint of metabolic activity, has a specific quality I know on site. The Challenger Deep samples had that quality. My first thought was contamination. Sample contamination is the constant enemy of deep water chemistry work. Trace amounts of material from the collection equipment, from the sample bottles, from handling during transit, can introduce artifacts that look like real chemistry if you're not careful. I requested duplicate analysis on both samples and flagged them for additional quality control checks. The duplicates confirmed the original results. I sat with that for a day before I did anything else. Confirmed contamination produces inconsistent duplicates. Consistent duplicates mean the chemistry is real. The dissolved organic carbon elevation was real. The trace metal signature was real. Something in those samples was telling me something. I went back through every available Challenger Deep sample dataset I could access, published cruise data, unpublished institute archives, data submissions to the international ocean chemistry repositories going back decades. 17 years of processing Pacific water chemistry means I know where to find old data and how to read it. The anomalous chemistry wasn't in any of the older samples. The historical Challenger. Deep data, going back to the earliest systematic sampling in the deep trench, showed the baseline I'd been working from for 11 years. Stable dissolved organic carbon at the established concentration. Trace metal ratios within the expected range. The chemical portrait of deep water that had been sitting undisturbed in the darkness at the bottom of the world for long enough to reach equilibrium. The anomaly appeared for the first time in samples collected 2 years ago. A cruise. I hadn't been the primary analyst on. Samples that had gone through a different lab before the Institute received copies of the processed data. The elevation was smaller in those first samples than in the most recent ones, but it was there. And in every subsequent sample set from the Challenger Deep region since then, it was present, and it was larger than the time before. I mapped the anomaly through the water column using every sample set that included multiple depth levels. The chemical signal was strongest at the deepest sample depths and decreased moving upward through the water column, a concentration gradient that pointed in one direction. Gradients in water chemistry mean diffusion from a source. The source was below the deepest samples. The source was at the bottom. Something at the floor of the Challenger Deep was producing the chemical signal that was diffusing upward into the water above it. I thought about what produces dissolved organic carbon and trace metal signatures consistent with biological processing in a location with no known hydrothermal vent field and no known biology of the relevant scale. I didn't write down what I thought. Not yet. I sent the full dataset to Dr. Remy Osei and asked for his interpretation. Remy is a chemical oceanographer at an institute in Woods Hole who specializes in hydrothermal vent chemistry and the biological communities associated with vent systems. He spent 20 years working on the chemical signatures of deep-sea biological activity, which made him the right person to ask. I sent him the data without context, just the sample depths, the concentrations, the trace metal ratios, and a note saying I'd appreciate his read on what the chemistry suggested. He called back in 2 days. His first question was where the vent field was located at the collection site. I told him there was no known vent field in the Challenger Deep. No hydrothermal activity had ever been documented at that location. He was quiet for a moment. Then he said the chemistry profile looked like vent-adjacent biological activity, not the signature of the vent fluid itself, but the signature of the biological community that establishes itself in vent environments, the chemosynthetic organisms that use the vent chemistry as an energy source and whose metabolic processing leaves a specific mark in the surrounding water. I asked him what scale of biological community would be required to produce that signal in open water at that depth. He was quiet again, longer this time. Then he gave me a number, a biomass estimate, the mass of biological material required to produce the dissolved organic carbon flux implied by the concentration gradient in my data. I didn't write it down immediately. I looked at the wall for a moment first. Then I wrote it down, and I looked at what I'd written, and I understood why Remy had been quiet before saying it. I queried the seismic archives. I'm not a seismologist, and I want to be clear about that. What I know about seismology is what a non-specialist learns from adjacent work in ocean sciences, which is enough to know how to search the public databases and what the basic parameters mean, not enough to do sophisticated analysis. I searched the publicly available records for seismic events at the Challenger Deep location, and I specified a date range around the time the chemical anomaly first appeared in the sample data. I found one event, small, magnitude small enough that it hadn't made any of the standard earthquake catalogs that get reported publicly. Recorded on 3 seismic stations, which is the minimum number required to locate an event, which meant this one had barely been detected. The reported depth placed it at extreme depth, directly below the deepest point of the trench. The date was the same week as the first cruise that had collected the anomalous samples. I looked at the timing for a long time. Before that event, the Challenger Deep chemistry was baseline, stable for as long as the sampling record went back, the undisturbed chemical signature of water that had been sitting in the dark at the bottom of the ocean for centuries without anything changing it. After that event, the chemistry began to change. The line between those two states was a single micro-seismic event, too small to make the news, recorded on 3 instruments, occurring at the deepest point on Earth 2 years ago. Something shifted that week. Something that had been still for longer than the chemical record covered became active. And since it became active, the chemistry of the water above it had been changing week by week and cruise by cruise in one direction, in a way that meant whatever was producing the change was producing more of it than it had been the week before. I sat with the seismic data and the chemistry data side by side for a long time. Then I went looking for the dissolved oxygen numbers. Dissolved oxygen in deep water is supplied by the sinking of cold, dense surface water that carries oxygen down from the atmosphere during deep water formation. In the deep Pacific, the oxygen concentrations are low because the water has been out of contact with the surface for a long time, and whatever biology exists at depth has been consuming oxygen slowly across that span. The established profiles are well documented, and the concentrations at any given depth in the Challenger Deep region were within a predictable range. I went back through all of the dissolved oxygen data in the Challenger Deep sample sets, the same historical search I'd done for the organic carbon, and I mapped the concentrations over time at the deepest sample levels. The oxygen was declining, not dramatically, not in any single cruise's data in a way that would stand out clearly on its own. But across the 2-year span, Since the chemical anomaly began, the dissolved oxygen at the deepest sample depths had been dropping consistently below the model predictions for that location and depth. The water was being depleted of oxygen faster than the established circulation models accounted for. Something was consuming it. I calculated the rate of oxygen consumption implied by the depletion trend. This required knowing the volume of water in the affected depth range and the mixing timescales, which I could estimate from the historical circulation data. The calculation wasn't precise, but it was constrained enough to give me an order of magnitude. I ran it once and looked at the result. I ran it again. Third time. All three gave me the same order of magnitude. The metabolic activity required to consume oxygen at the rate implied by my data was not the activity of a vent-adjacent microbial community of the kind Remy had described on the phone. The number was larger, considerably larger, large enough that when I translated it into a biomass estimate using standard metabolic scaling relationships, the result was something I sat with for the better part of an afternoon before I called Remy back. He listened to the oxygen analysis without interrupting. When I finished, he said he'd like to run the numbers himself and asked me to send the oxygen dataset. I sent it. He called back the next morning and didn't say anything for a moment when I picked up. Then he said his calculation agreed with mine. I asked him what he thought we were dealing with. He said he thought we were dealing with something that didn't have a good parallel in the published literature on deep-sea biology, and that he wanted to think carefully about how to characterize it before either of us said anything more specific. I told him I thought that was reasonable. We've been thinking carefully about it for several months now. I filed a technical note 6 months ago attributing the Challenger deep chemistry anomaly to a possible uncharacterized chemosynthetic community associated with undiscovered geological activity at the trench floor. The language was accurate and incomplete in carefully chosen proportions. The anomaly is real and documented, and the chemosynthetic community framing isn't wrong. It's just not sufficient. And anyone who runs the oxygen numbers the way Remy and I ran them will find out how insufficient it is quickly enough. I haven't gone further than the technical note. I've thought about why, and the answer is that going further requires a community size estimate, and a community size estimate requires saying a number that doesn't fit inside the category of community. The category breaks before the number fits into it. I keep processing samples. The Institute gets water sample sets from the Western Pacific on a regular schedule, and my job is to run them and document what the chemistry shows. New Challenger. Deep samples come in roughly every 4 to 6 months, depending on cruise scheduling, and I process them the same way I process everything else. I know before I run the analysis what the results will show. The dissolved organic carbon will be elevated above the previous sample set. The trace metal ratios will reflect the same biological processing signature they've reflected in every sample since the anomaly began. The dissolved oxygen at the deepest levels will be lower than the model predicts. I run the analysis anyway because the record requires it and because documenting the progression matters even if I don't yet know what the documentation is for. The chemistry is always what I expect it to be now, and that's its own kind of unsettling that I've been doing this long enough for the abnormal to become the new normal in my understanding of what that water should look like. I think about the micro-seismic event, a tremor too small to make any public catalogue, recorded on 3 instruments at the deepest point on Earth 2 years ago. Before it, the chemistry was stable. After it, the chemistry began to change. Whatever is at the bottom of the Challenger Deep had been still for long enough that the water above it had reached chemical equilibrium with its presence, whatever that presence was in its dormant state. The baseline I'd worked from for 11 years was the chemical signature of something that wasn't moving. The chemistry, since the micro-seismic event, is the signature of something that is. I think about what it means that the rate of change is increasing, not stable, not the flat signal of a biological community that's reached steady state with its environment, increasing, cruise after cruise, in a way that means the metabolic activity producing it is greater now than it was last month, and was greater last month than the month before, growing. Whatever woke up 2 years ago at the bottom of the deepest trench in any ocean on Earth has been getting more active since it woke up. I think about the micro-seismic event, and I think about stillness, and I think about what a long stillness implies about the thing that was still. The Challenger Deep has been sampled since the 1950s, not frequently, not systematically, but enough to establish that the chemistry was stable across the span of the record. Whatever is down there was still for at least that long, and probably much longer, since the chemical equilibrium that the historical baseline reflects takes longer than 70 years to establish. Something that was still for long enough to let the water chemistry above it reach equilibrium had been still for a very long time. 2 years ago, it stopped being still. I don't know what changed. The micro-seismic event was small and deep, and I don't have the seismological expertise to tell me what produced it. Something shifted at the bottom of the trench. A geological adjustment, a change in pressure, something that altered the conditions enough to interrupt whatever state the thing below had been in. I don't know what that state was. I don't know if dormant is the right word, or if something operating at that scale and that age experience anything that the word dormant applies to. What I know is the chemistry. The chemistry says something metabolically active is at the bottom of the Mariana Trench. It says the activity has been increasing for 2 years. It says the thing producing the activity is large enough that its oxygen consumption is measurably altering the chemistry of the water column above it, and the size implied by that consumption is not a size I can sit with directly for very long before I have to put it down and do something else for a while. Remy and I talk every few weeks. We've gotten careful about what we say directly and what we leave in the space between what we're saying, which is its own kind of communication once you get used to it. He's been going through the published literature on deep-sea biology looking for anything that bears on what we're seeing. He sends me papers occasionally. I read them. None of them have a framework for the numbers we're working with. The Institute is scheduling another research cruise to the Western Pacific next year that will include a Challenger Deep station. I'll process those samples when they come in. I'll run the same analysis battery I always run, and I'll document what the chemistry shows, and I'll add the results to the record I've been building for 2 years. I already know the dissolved organic carbon will be higher than the last sample set. I already know the oxygen will be lower. I already know the trace metal ratios will show the same biological processing signature they've shown in every sample since the anomaly began. I'll run the analysis anyway. That's the work. Whatever is at the bottom of the Challenger Deep, I'll never see directly. I'll never be on the ship that goes there, and I'll never look at images from a camera lowered to that depth, and I'll never stand anywhere close to 11 kilometers of water with something living below me. I only ever see what it leaves behind in the water above it, the chemical traces of its activity diffusing upwards through the darkness and arriving in my sample bottles weeks or months after they were collected, carrying information about something I'll spend the rest of my career understanding only in inference and implication. The inference is enough. The implication is more than enough. Something at the bottom of the deepest place on Earth woke up 2 years ago, and the water above it has been different ever since. And every sample that comes through my lab tells the same story in the same chemical language I've spent 17 years learning to read. I read it. I write it down. I'll read it again when the next samples come in. The numbers will be larger than the last time. They always are now.